Disclaimer. First, this is a critique on the current trend to view our universe as a simulation, which I personally find intellectually lazy and subtly nihilistic. Multiverse theory also fails for me for those same reasons. And second, I did use Gemini, ChatGPT, Claude, and Grok in editing this essay. I do not propose an actual answer. This essay is food for thought. As we are currently trapped in the bias of our own technological era. Historically, humanity has always projected its most advanced engineering onto the cosmos. When we built that first complex gears, the universe became a clockwork mechanism. In the industrial age, it became a thermodynamic engine. Today, because we build our systems in discrete bits, voxels, and binary grids, we have unconsciously projected this architecture onto reality itself. The prevailing pop physics metaphor of our time is simulation theory, the idea that reality is a digital construct running on a cosmic hard drive, fundamentally quantized into discrete pixels. But this is a category error born of a computer age bias. To escape this trap, we cannot simply build more theoretical artifice or meta-level abstractions. We have to dig down into the base metal layer of reality. When we do, the assumption of a discrete digital grid fractures. Instead of a pixelated simulation, a far more rigorous framework is to view reality as a substrate intrinsic field array. Defining the field array, this is not arbitrary jargon, but a necessary departure from spatial limitations. Modern thought often tries to map higher dimensions as rigid geometric shapes, but a field array is a continuous, dynamic matrix of wave interactions. It is substrate intrinsic because there is no separation between the hardware of space and the software of physics. In a computer, memory and processing are separate. In a field array, the physical interaction itself is the record. The universe does not need to compute its next state. Its physical state is fundamentally bound to the substrate itself. The optical holography analogy to visualize how a continuous field array processes information differently than a digital grid. Optical holography serves as a vital mechanical analogy. To be explicitly clear, this is a reference to the physical mechanics of laser holography on photographic plates, not the holographic principle of black hole thermodynamics or AS/CFT correspondence. When a physical hologram is recorded, it does not chop light into a discrete grid. Every single microscopic point on a photographic plate stores phase and amplitude data from the entire light field through continuous, overlapping wave interference. The information is distributed holistically. If you attempt to digitize a true holographic interference pattern, you instantly hit a massive data bloat problem, requiring terapixels just to approximate a single static frame. This exposes the massive computational friction that occurs when you try to force a continuous physical process into a discretized digital schema. It demonstrates that continuous wave encoding is an inherently different physical regime than digital sampling, one that does not suffer from the artificial resolution limits of a pixelated bit. The misinterpretation of the Planck limit. The most common defense of a digital universe is the existence of the Planck length and Planck time. The assumption is that because there is a smallest mathematically measurable unit of space and time, the universe must be snapped to a digital grid. That Planck units are the fundamental clock cycles of the cosmos. This fundamentally misconstrues the limits of our own models. While theoretical physics remains fiercely divided on whether spacetime is ultimately discrete or continuous, assuming Planck limits are binary discretizations is a massive leap. They are not necessarily the 3D voxels of a rendered video game. It is equally plausible that they represent an operational boundary, the exact scale at which our current mathematical frameworks for measurement and localization break down. Rather than a hard pixel, the Planck limit can be understood as the threshold where a continuous wave fabric becomes so tightly bound that it can no longer be sliced any thinner without losing phase coherence. Escaping the metaphor, replacing a digital universe with an analog one is ultimately just swapping one human technology for another. The deeper truth is that the universe is not a machine built in our image. By conceptualizing the base metal of existence as a substrate intrinsic field array, we bleep away the artificial constraints of the modern computer metaphor. We are not living in a cosmic hard drive running a discrete simulation. The universe is its own physical substrate, a continuous matrix where the physical state and the recording medium are structurally identical.